Good day, and welcome to Africa Teen Geeks. This is a STEM digital school. My name is Nkulego Matondo. I am your grade 12 physical sciences teacher. Today is the 24th of July 2020, and we are continuing with our assessment. So, yesterday, if you guys remember properly, we had an assessment, and today we are going to be doing the memorandum for that assessment that we had yesterday. Okay. So that I hope that everybody's having a good time. Guys, this is grade 12. This is metric. This is a do or die. I hope that you all understand what is going on. And this test is basically a it's just like maths. You need to practice to understand how to do your work better. Okay. So we had our paper yesterday, and we started off with our first question, which says that I think it's a sound wave and light kind of question. It says the siren of a bus, which is traveling at a constant speed along a straight horizontal road, emits sound wave at a constant frequency. So detector P is placed inside the police car, and detector Q is placed next to the road at a certain distance away from the car. So the two detectors record the changes in the air pressure readings caused by the sound waves emitted by the siren at a function of time. So the graph below were obtained from the recorded results. So the first graph is the air pressure versus the time recorded by detector P in the car. As you can see how it goes in, we've got our time and we've got our air pressure. So on graph B, we've got our air pressure versus time recorded by detector Q next to the road. So today we're working with air pressure versus the time. Okay. So we're still on the Doppler effect. So it says here, calculate the frequency of the sound waves recorded by detector P. Okay. So detector P is the detector in the car. So they want the frequency of the source basically. And we know that when the um, when the listener or the observer is standing still, the one on detector Q, the the VL is going to be 0, and the sound is going to be the one for P is going to be a VS, right? So I think that the car is moving towards that standstill listener, and that's going to mean that our V is going to be a 1, right? A minus. Okay. So what they want to know here is 1.1.1.3, which says calculate the frequency of the sound wave recorded by the listener. Okay. So we are here. So the frequency, there's three options that we can use to calculate the frequency, right? So I've written them all down so that we can have options, okay? Because there's many ways to kill the cat. So the easiest option is the first one, which says frequency is equals to 1 divided by time. And in this case, it's going to be 17. We get it from here, which is 17. Calculate the frequency of the sound, which is here. Remember, now we are working with detector P. So if the sound is here, it's going to be 17, right? The time. So the easiest one will be 1 over time, and that will be 5.88 times 10 to the power of 2, and that will be equals to 588.24 hertz. So that is our first option. This is our easiest option we can use to calculate the time. And then we've got a second option where we can say speed is equals to distance divided by time. Distance is not given, is what we're looking for. So we know that the speed is 340, and we know that the time is 25.5, which is the total time, right? And therefore, um, we're going to get our distance, which is going to be 0.867. So the distance for 1.5 wavelength, right? So our wavelength is going to be equals to 0.578, and therefore now we can go and calculate our frequency, which is equals to velocity is equals to frequency times wavelength. And now we're going to make the frequency the subject of the formula, and that is what we're going to get. Okay guys, I hope it makes sense to you. But now we also have another option 3 that we can use to also calculate, where we say velocity is equals to wavelength divided by time. And we've got our velocity as 340 meters per second, and we've got our time as 17 times 10 to the power minus 4. And we're going to have our wavelength, right? After we find our wavelength, we go back to this formula where it says velocity is equals to frequency times wavelength. And we make the frequency the subject of the formula, and we're going to get the very same answer. But I think that this one is the best one because it's much simpler and it's less complex. So that is our answer. So now we move on. It says block P of mass 2 kg is connected to block Q, a mass of 3 kg, by a light inaccessible string. Both blocks are on a plane inclined at an angle of 30 degrees to the horizontal. So block Q is pulled by a constant force of 40 Newton at an angle of 25 degrees, which you see right here, to the incline. Block P moves on a rough section, as you can see here. It's a rough section, which means there is friction. AB of the incline, while block Q moves on a frictionless section, BC of the incline, as you can see with the diagram below. So an average constant frictional force of 2.5 Newton acts on block P. Block P, we've got it's going up, but it's got a frictional force of 2.5 Newton as it moves from point A to B. So what they want to know is on 2.1, you need to state the Newton's second law in words. Okay, so number 2.2, they want us to draw a free label, a labeled free body diagram of block P. And okay, let's start with number 2.1. Let's state the Newton's second law. So what the Newton's second law states is that when a resultant force acts on an object, the object will accelerate in the direction of the force with an acceleration that is directly proportional to the force and inversely proportional to the mass of the object. Okay, so we know force is equals to when they say when a resultant force acts on an object, the object will accelerate in a direction of the force of an acceleration that is directly proportional. So it will be A over M, right? If you just look at the if you try and equate it, it's going to be a resultant force acts on an object. The object will accelerate at a direction of the force with an acceleration that is directly proportional to the force and inversely proportional to the mass of the object. So that is your 2 marks right there. So number 2.2 says draw a labeled free body diagram of block P. So there we have it, right? Block P is this one right here. We've got a frictional and we've got a applied force. This one is going to be our applied. This one is going to be a friction that's going that way. Then we've got our gravitational force, and we've got our normal force moving upwards. Okay, so let's see. So you see, this is exactly what I meant. The F is the frictional force, and this one is the applied force. In this case, it's a tension, and this one is the normal force, and this one is the force due to gravity, gravitational force, basically. Okay, so that's how we're going to have it. So in N, you need to also state that N is your normal force, F is your frictional force, W is your weight or gravitational force, your T is your tension or applied force. You can also write it as applied force. So you need to make note that a mark is awarded for the labeling, for the label and arrow You do not penalize for the length of the arrow, so it doesn't really matter as long as it shows the direction. You deduct 1 mark for any additional force that you have made onto the graph. Okay, so you lose a mark for that. And then next, if the force do not make contact with the body or dot, you minus a force. Okay, so if the arrow is missing, you minus a point as well. Okay, because we need to know what is the direction, and the arrow is what shows it. Okay, so now we move to number 2.3. It says calculate the magnitude of the acceleration of block P while block P is moving on a section AB. So now we're looking for the acceleration of block P. Okay, so we're gonna have our force net, right, which is gonna be equals to the mass times acceleration. Then we're gonna have our forces, which we're gonna have friction, which is moving in the opposite direction. Remember, guys, we are taking the forces that are parallel to the direction, the displacement, right? So we're going to have our friction, we're going to have our tension, yes, which is going to be Fx plus the gravitational force plus the friction. Okay, so Fx is the one for the applied, which is going to be 40 cos 25. Let's just go back to it. We have this one, right? 40 Newton. Okay, which is the applied force, and it's at an angle of 25 degrees. Remember, this is the pulling force, right? The F of x. And then we're going to have the one due to gravitational, our gravitational potential, which is going to be, remember, as I said, both blocks are on a plane inclined at an angle of 30 degrees. So at this angle, we're going to have our gravitational force right here, 9.8 times sine 30. 8 sine 30 because we're going to be using a component of it, right? We're using the parallel component, not the perpendicular component. And then we've got our force friction, which was already given as 2.5 Newton, and that will be equals to the mass which we have, which is equals to 5, and the acceleration that we are looking for. So you see how long the net force is. So you always need to make sure that you have all the forces that are acting on an object. Okay, you must have all the forces acting on an object. So our acceleration will be equals to 1.85 meters per second. Okay, then we move to 2.4. If block P has now passed point B, how would the acceleration compare to the one calculated in this 2.3? Choose from greater than, smaller than, or equal to. So this will be greater than, or the force, the net force will increase. Okay, because there's no friction and the surface is smoother. Okay, remember with the first one, while it was passing here from A to B, the ground was rough, so it had friction. So once it comes to this side, it's going to have a much smoother pathway, and it's going to be greater. Okay, so that is our number 2. So now we move to our last question, which says that a stone is thrown vertically upwards with a speed of 10 meters per second from the edge of the roof of a 40-meter high building, as shown on the diagram below. Ignore the effects of friction. Take the ground as reference. Number 3.1. Define the term free fall. So what do we know about free fall? Free fall is a motion during which the only force acting on the force is gravity. Okay, so there's no friction, there's no air resistance. So that's what a free fall is the only force acting on the force of gravity. The only force acting on the motion is the force of gravity. Okay, and then we move to number 3.2. It says calculate the maximum height above the ground reached by stone A. So which is this one? Stone A. They want this height here above the ground. No, they want this piece of height here. So it's going to be at the eventually you're going to say this total height minus 40 gives us what we need here. So now we need to calculate the total force. Okay, and how we're going to do that? Okay, upward force, upwards, as we're going to take upwards as positive. Okay, so we're going to say v final square is equals to v initial square plus 2 change in acceleration 2a times change in change in y, right? Then we already have everything. The final velocity is 0, the initial velocity is 10, and we've got 2, and we've got the acceleration as minus 9.81. Okay, and we're going to have our change in y. Our change in y is going to be 5.1 meters. Okay, so now we're going to say the height is equals to the 40 that we already have plus 5.1, and that is going to give us 45.10. Okay, because they want the force above the ground. Okay, the height above the ground. So either way, there's two options. If you take the downwards as positive, nothing much is going to change, but this one, you're just going to make your velocity negative and your acceleration positive. That's basically all that's going to change. If you had to change, if you take it downward as positive. Okay, are we good to go? So on number 3.3, they ask write down the magnitude and direction of the acceleration of stone A at the maximum height. Okay, the magnitude and acceleration. So it's going to be 9.8 meters per second minus 2 downwards. Okay, it's going to be downwards force. Then you move to number 3.4, which says stone A passes stone B when the two stones are 2.29.74 meters above the ground. Calculate the value of x. Okay, so saying here stone B is dropped from rest from the edge of the roof x seconds after stone A was thrown upwards. So we need now the value of x, which is the x seconds. So first we're going to calculate the time, right? It's going to be Vf is equals to Vi plus a change in t. This is going to be a 0 equals to minus 10, as we already have the initial velocity, plus 9.8 times triangle time, right? And this is going to be triangle t will give us 1.02 seconds right there. Okay, so now we find the s basically, which is will be the change in s is equals to v triangle t times half a t squared. We're going to use that equation. From there, we're going to substitute our s equals to 0 plus half 9.8 triangle t, and we will have our seconds. So now we've got 2 times, right? So that the change in total time is going to be the 1.02 plus the 1.77 seconds. Okay, that's for the stone A. We're going to go down the same route. First, we're going to find the y, the one where we say t plus half at squared, and that here we're going to substitute given 0 plus is equals to 0 plus half it to the 1.45, and that will give us 1.34 second, which means this is our time. Okay, this is our time. So this is our time where this is the time, because they said when they pass each other. Okay, what is the value of x? Okay, so now we move on to the graph of position versus time for part of the motion of both stones are shown below. Okay, so which of the tables A to H on the graph above represents each of the following? So here now they want to know for 3.5.1 the time at which the stone A has a positive velocity. So this stone A has a positive velocity. It's going to be from A to B, right? So let's see. It's going to be number D, which is right here. So this is where our stone A will be positive. Will have positive velocity. So the maximum height reached by stone A is going to be at point E, right? At point A. Or they're using the the values on this side. I was using the values on that side, right? So this is going to be at point A, but it's also at point E. So it could be E or A. Okay. Oh, but they asked labels A to H. So now they want to know the time when stone B was dropped. It should be around this time, right? So it's point F. Yeah, it is this time. So it can either be F or it can be, oh, this is a position in meters and this is the time. Sorry about that. So if they say the time, then we're going to take F. But maximum height would not take the time, we take the position, which is A. Okay. And then the height at which the stone pass each other. It's going to be at point C, right? And that is the end of our this is the end of our lesson, guys. Thank you guys so much for joining me here on thank you guys so much for joining me here, and thank you. This was our revision for our assessment that we had yesterday. I hope that everybody had the correct answers and you are ready for term 3 test or exam that you can receive at school. During this time, please make sure, guys, that you do your revision correctly. Okay. My name is Nonkulego Matondo. I am your grade 12 physical sciences teacher, and good day.